Welcome, Alex. I'm very happy to have you here. Layer 2s are heating up over the last couple of months, and there's a lot of misunderstandings, in general, just misinformation, I would almost say, as well, about what ZK is, what Layer 2s are, and how it differs from other approaches to scaling. So welcome, Alex, obviously founder of ZK Sync.
Thank you, Larry. Excited to be here.
Awesome. So I would just like to kick off immediately with something that you tweeted, I think, yesterday. You had this tweet that talked about how the core functionality of Ethereum is verifiability and how ZK is the end game to solve that, to be able to scale what's actually verifiable. And that goes very, kind of on the opposite spectrum of what some other scaling approaches are doing, where it's not necessarily verifiable. Can you expand on those topics a little bit more and talk about why that's important for everyone that's actually listening? Because the argument that I hear frequently, I'm sure we're going to get it on this podcast as well, is like, I don't really care if it's verifiable or not. Like, all I care about is it's easy for me to use, and it's friendly for retail. So what's your response to that, and can you expand a little bit more on the verifiability topic and why you think ZK is the end game?
That's a fantastic question. And indeed, a lot of people are of the opinion that some of the properties of blockchains are not important and you can just bypass them and all users care about is UX. But in reality, there are two types of truths. There is a political truth and there is a scientific, like some form of objective truth of what how things are. The political truth is what we all agree things are, and you can try to convince people and manipulate their opinion. But there are fundamental, there is some value in a car or in certain types of technologies. And no matter how hard you try to persuade people about something, like if there is a value in one thing and less of this value in the other thing, eventually this first thing will have more utility, will have more usage, and will kind of dominate the market. So, in my opinion, the function of Bitcoin, Ethereum, and all of the public blockchains is coming to consensus on verifiable computation. Like this has been true for Bitcoin. This is like Bitcoin started as a decentralized payment network, which with the maxima of don't trust, verify. And this expanded into Ethereum with adding more functionality in terms of expressibility of smart contracts. But ultimately, if you don't care about verifiability, it's a database. Verifiability is what turns a distributed database into a blockchain. And this matters. People are willing to pay huge premium for transactions on Ethereum that cost many hundred times more than transactions on analogous chains, because it's the most secure, the most decentralized, and the most resilient settlement layer. This resilience is very important. The resilience of Bitcoin and Ethereum can withstand attacks from like super powerful attackers, from basically nation states. You cannot really shut the network down simply. You cannot have some very powerful actors dictate their rules. You have credible neutrality encoded at the protocol level and enforced by everyone. And the only way to enforce it is by having transactions that are fully verifiable. Verifiable means it does not mean that you need to verify them. It means that you can verify them from the ground up. You can verify the software that your node is consisting of. You can verify the math and cryptography behind elliptic curve signatures. You can verify cryptography behind hashing. Every single step in this stack can be checked and was checked by many people, and so laid out as an open source, so anyone can look into it, and many eyes are in fact looking into it. And so like the network effects that are coming from the fact that you have the most secure and resilient settlement layer in the world are massive, because it's not only individuals, it's also the institutions and enterprises and even nation states that are tapping into those network effects. This is what you really want to scale. So by scaling blockchains, we really should be scaling verifiable computation. And the only technology that we have today that can do this is zero knowledge proofs. Anything else without zero knowledge proofs does introduce trust assumptions or lower security or lower throughput, because you cannot make everyone in the world verify all the transactions in the world.
And so when the counter argument of people, I'm not saying that I agree with this, is that verifiability and decentralization is kind of a spectrum, right? And so do you think that verifiability, by your definition, is a spectrum or is it a binary thing? Like, is something like, how do you decide if something can be shut down by state actors? Is that something that you think like can actually scientifically be proven? Like this is how much money it would cost, or it's something that is still to us, kind of an unknown, and we don't really know, can Solana be shut down by the US government if it really tries? Maybe. It's hard to say. I think it's possible, but it's also possible it's not. Do you agree with that, or are you thinking of ways as a more binary definition?
For decentralization, I definitely agree that it's a spectrum. For resilience, we have to agree that it's a spectrum too. Like, what is more resilient, Ethereum or Bitcoin? They have slightly different properties. Some things are, like Bitcoin is better optimized for individual hardware. You can run it on a Raspberry Pi. Ethereum requires something like a laptop to run a full node today. This is going to change in the future, and we'll talk about it in a second. But yeah, like there are certain types of attacks applicable to one or another. Verifiability is not on the spectrum. Verifiability is binary. Either you can verify transactions yourself or you cannot. And you could argue like, okay, can the full node verify it? And maybe there is a spectrum of the hardware requirements for a full node. We could maybe agree to that. But let's just take a step back and consider the bigger picture. You have two different networks. One is way more resilient, way more secure, because the verifiability threshold is very low. Imagine that you can verify this network from any device, any end device. Let's say not just laptop, but also a smartphone or even your watch or any Raspberry Pi, any tiny controller. So this is one, and there is another network which requires you to run a computing cluster to be able to verify it and to be able to participate in consensus. And so like that's your minimum threshold. And let's say that both networks have all else equal, like the transaction costs are comparable, throughput is comparable, like basically throughput is unlimited in both cases, UX is comparable, and so on. Which one will you prefer? And this choice is going to be determining which one is going to be like 10x more important than, or 100x more important than the other one, because it's a world where for the settlement layer, it's a winner takes all situation. Like if you have the king, there is no second best.
To channel your inner micro strategy. So to follow up question on that, let's assume that eventually pure layer twos with ZK rollups are actually possible on Bitcoin. And let's assume that Bitcoin is the most, verifiable at the moment, at least the most secure by most definitions. Do you think that's more optimal to have ZK rollups actually function on Bitcoin than it is on Ethereum if it eventually becomes possible?
I would say this is eventuality. This is a very hypothetical question because Bitcoin is kind of ossified at this point. It's really hard to change the Bitcoin protocol and reach a broad social consensus that you need to get to this point, and which verifiability you use and so on. If we got at that point, it would then become a question. And I think the only contender Ethereum could have in this world would be Bitcoin. Like nothing else comes even close from the perspective of the root culture of cypherpunk and of this, like ultimate security mindset and resilience mindset that power the design of both protocols. So there we could be arguing, we could say, okay, in Bitcoin, like you have like arguably cypherpunk roots of Bitcoin are stronger than those of Ethereum. But on the other hand, you have proof of work which is maybe, like could be considered more centralized or less centralized. But if the controlling power, if the majority of hash power in Bitcoin is compromised, it's a situation which is very hard to recover from, because you would need to, like, you can change the algorithm and you can fork away with a different mining algorithm, but you need to bootstrap the economic security from scratch. And this economic security for Bitcoin is going to be very important. Whereas in Ethereum, if the majority of the stake is compromised, you can always fork away. The community can come together, the social layer, and they can slash the validators who are doing the equivocations, and you can basically continue uninterrupted without any decline in the economic security, because the rest is going to be as valuable as the whole, because that's going to be the canonical fork, right? So you could be arguing, like, I don't want to make this argument because, like, there are pros and cons, like, but this is a very hypothetical situation because Bitcoin doesn't support it. Today, only Ethereum supports smart contracts. Ethereum's culture is very, strong around these values. And so I don't see an alternative for Ethereum today.
And so your line of thinking is that the strongest technological approach will eventually win because the others will be, if other approaches become too large in terms of onboarding, let's say millions of retail customers, it becomes an easier target to be shut down or just targeted by a larger actor that can exploit it.
It will just become irrelevant. It will just make no sense. People like to talk about the fact that the best technology does not always win. They bring this example of, like, Betamax versus VHS and saying, like, the one protocol was slightly better, but the other won. But the reality is eventually Netflix won with web streaming. So, like, if you have a technology which is exponentially better for solving the same problem, you can still, like, go and watch videos on the tape. This is possible, and this accomplishes the same goal. But who's going to do that if you can just download it in one click, and you can have this infinite supply of video materials which are accessible like this, right? This is a better analogy to what's coming with ZK hyperscaling. Like, so let me picture you, like, let me give a better understanding of what's coming there with zero knowledge proofs. What are zero knowledge proofs? What is ZK? Like, ZK is maybe a bit of a misnomer. It should be called proofs of computational integrity, or scalable succinct proofs of computational integrity. These are cryptographic protocols that enable us to prove arbitrarily complex and long computation, and to verify this computation, the outcome, the result of this computation, in under 1 second on any available hardware, right? Very cheaply. It can also be verified by a smart contract on any chain, basically at a very small gas cost. So the beautiful part of the ZK protocols that emerged in the last 3 years, and only in the last 3 years, is that the recursive composability. So we can take a proof of a single block, a proof of a second block, and then we can generate a proof which verifies both of these proofs, which by transition verifies all of the transactions in both blocks. And then we can repeat this process with, like, block number 3, block number 4, and produce the proofs of proofs, the proof of proofs, and have a single proof which verifies 4 blocks. And then repeat this process and verify 8 blocks, 16 blocks, 32 blocks, ad infinitum. Like, there is inherently no limit on how much computation we can pack into this one single proof. And now, another beautiful part is that all of these blocks can be produced completely independently from each other. They can be run in, it can be a single parallelized blockchain. It can be many separate blockchains that run in parallel. But eventually, we're not blocking each other. They're not constraining. We can really expand to any number of users, transactions, amount of state, and pack all of that in a single proof, which we will settle in Ethereum. And then we are actually at the position to generate a proof of the Ethereum block itself. Like, ZK Sync is coming with this technology this year. You will be able to just verify arbitrary EVM computation and produce a single proof of the Ethereum block. And then we can recursively point also to the previous proof of the previous block. And this way you have a single proof which verifies the validity of Ethereum all the way back from Genesis and the validity of all the ZK chains that settle on Ethereum in this one proof, which you will check probably with your mobile wallet, like any wallet you use, like from MetaMask to anything else, will support that. And you will not need to trust Infura or like any API services, node providers. You will not need to trust Ethereum validators. No, not the validators of all of these thousands of rollups of ZK chains that are settling on Ethereum in this single proof. It's completely infinitely scalable, verifiable computation to like compressed into a single point, the ZK singularity, if you want. This is insanely powerful, like insanely powerful. Like you can't overestimate how important this moment is going to be, where you lower the requirements from, like Ethereum gets a lot of critiques for, oh, you guys have to run the, like most of Ethereum full nodes are running on AWS, and it's not really decentralized. That is changing. Like every single smartphone in the world will become an Ethereum full node. Not a light node, not a light client, which only checks the headers. Actual full node, which verifies every single transaction that happened on the network. That is insane. Like this cannot compete. Like why would you choose anything else if you can have 100% mathematical guarantee of correctness of all transactions, holding everyone accountable? And this expands and like infinitely, just like the internet. So let's take the UX view, like go one step in a different direction. In the internet is interconnected. It's infinitely expansible. You can have many websites. You're not bound. If you're a user of Google, you have a Gmail account, doesn't mean that you can only browse Google websites. You can browse any websites, and any website is connected to or can be connected to any other website in exactly one click. You have a hyperlink, you do one click, doesn't matter what domain, how many servers, how many router hops away, like maybe you're on a different continent from the server that hosts this page, doesn't matter. One click, 1 second, you're there, the page is downloaded, right? And this expands like more users, like 10 billion, like 1 billion users, 10 billion users, doesn't matter. It will just grow with the demand. We cannot do it today with blockchains for very fundamental reasons. Because if you do that with Bitcoin and Ethereum, you would have to verify like these billions of transactions of all these users, which obviously just won't work. And you cannot have like all the state, all the witnesses of the state for those transactions. It's just physically not possible. And if you say, okay, we're going to have a lot of these chains that are completely disconnected, not tied together by Ethereum, then you have a problem of bridgeability and connectivity between them. We'll talk about like let's postpone this for a second. We'll come back to this question, right? But in this network, you can have something where you can transact from any address on any of those thousands of rollups or ZK chains to any other address, to any other user or smart contract in exactly one click. You do one confirmation in your wallet, and then the transaction goes there, does something like atomically composable, like maybe you want to do a swap, like you are on a generic purpose chain. Let's say you're in the zkSync era, and then you want to do an exchange on like some Uniswap chain. You send money there, it goes, makes a swap, comes back, all of that in a matter of seconds and fully trustlessly, and it's going to cost you no more than a single transaction on your chain and a single transaction on this other chain. You don't have a bottleneck of the intermediate chain where you would have to go through this one single bridge and it's going to be super expensive. Like think of going from one rollup on Ethereum to another rollup today. Yeah. You can do it trustlessly, but you would have to bridge from this rollup A to mainnet on Ethereum, and then from the mainnet to rollup B, and it's going to cost you $10 or like $50 or whatever the gas prices are today. Although the transactions on both rollups are just 1 cent, right?
Right.
1 cent here, 1 cent here, $50 for the bridging. Now, in this scenario which I'm describing, in this infinitely expansible ZK network, you pay 1 cent here and 1 cent here. In fact, in the zkSync architecture, you will pay half a cent here and half a cent here because you only have to pay for the state diffs. You only pay for the accounts that you actually modify in this block. But those are nuances. Like, doesn't matter. Think like 1 cent connection from any point to any point. Like, this is massive. It's not possible with traditional bridges because the way they work today is they essentially custodian like multi-sig accounts with some like you can have some optimistic methods. You can even add some ZK like verifiability if the chains are ZK verifiable. But ultimately, your problem is in the current architectures that you have to maintain pools of liquidity on both sides, right? You have some liquidity on, let's say you want to connect two optimistic rollups, right? Native bridging takes 7 days. Not feasible. No one is going to wait 7 days, right? So you want to transact from Optimism to Arbitrum, and you want to send like 100 ETH. You can do it fast, but that means that someone has to take the 100 ETH from you on Optimism, park it to their wallet, and have available instantly 100 ETH on Arbitrum, which they're willing to give to you. And so you're already limited by like only the most fungible tokens. You cannot do it with NFTs. You cannot do it with some like long tail tokens on the most fungible ones. But then the bridge operator has to maintain these balances. So they have capital costs. There is a cost of having capital idle in those systems. They have to pay those costs. So the bridging from Optimism to Arbitrum will cost you some percentage of the value that you're transferring, and it's not a cheap percentage. It's pretty high, right? In the ZK chain, in this extensible ZK network, you only pay gas fees. You only pay the transaction, like the basic flat 1 cent fees or whatever. If it's a Validium, it's going to be even lower than that. Hopefully we can afford, most people will be able to afford rollups and have most of their assets in the rollup, and maybe some like lower, current spendings on some Validiums or Volitions, but it's just going to be this 1-2 cents. It's a massive difference, right? Especially for large amounts and especially for NFTs and basically passing arbitrary messages. Yeah.
That was an extensive answer, but that was really, really good and detailed. Follow up on that. So, we're talking about the technology broadly so far. Obviously, you guys at ZK Sync have slightly different approaches to other ZK rollups that currently exist. There's Polygon, there's Scroll, there's Starknet with a completely different approach, and then there's obviously the optimistic rollups. So can you describe for our listeners a little bit like how does your approach differ from the other ones, especially the ZK focused ones, and why do you think that's the right way to go forward? Specifically, generally people don't find much of a difference, at least the non-technical ones, across the EVM ZK chain. So whether that be ZK Sync, Scroll, or Polygon ZK EVM, there's obviously slightly more of a noticeable difference on Starknet. But can you talk a little bit about your approach and how it differs from everyone else?
Absolutely, happy to. So let's start with optimistic rollups. As I just said, they are fundamentally not connectable. So they after EAP 4844, which happened last week, the costs dropped massively for everyone. And so optimistic rollups are like slightly under 1 cent. ZK Sync is like around 1 cent per transaction. So it's kind of negligible from the consumer perspective. You don't really care anymore. But you cannot really connect them. You can connect them to anything else outside. So if you have multiple optimistic rollups, to send an NFT from one to another will take you 7 days. And this isn't, it doesn't go there. I think they kind of all agree that ZK is the future, and they may be hoping to upgrade to ZK one day. But if you don't put it there in the beginning from the start in your architecture, it's gonna cost you a significant effort to rewrite all of that and just migrate. So like it might be easier to just like drop those chains and migrate and just bridge over to a new ZK chain and just start from that. So I'm not going to cover them. I think it's a gone story. On the and like maybe one like even there, you, in addition to the security mechanisms and optimistic rollups, to the best of my knowledge, none of them have permissionless fraud proofs yet. Like Optimism is coming with the fraud proofs for the first time. They're only on testnet, not on mainnet. Arbitrum doesn't have permissionless fraud proofs. But what we saw, what was quite impressive, was that Base got a lot of usage after AP4844. The usage surged, and they came back now to like 20 cents per transaction on average, right? Whereas like they yesterday I just checked the stats. Yesterday they did like almost as many transactions as ZK Sync, but the cost of ZK Sync is like 1 to 4 cents, and for Base it's like 5 to 20 cents. Which is very, very interesting. It points that it's not enough to just have the security mechanisms properly done, and like data availability is not the only bottleneck. Your execution capacity is another bottleneck. And if you hit that, you will have to raise the costs. And you need to master both the engineering side and the data availability compression. And I think we've done it really well. If you compare us to everyone else, if you go to l2bit.com and you go to the activity page and sort by max daily recorded TPS, ZK Sync is way on top, with like over 60 TPS recorded for continuously for a period of 24 hours. Back in the day when Inscription Frenzy hit every chain and like kind of was battle testing them. On the peak, we recorded something like 200 TPS for a shorter period of time. And on testnet, we currently have a version of the virtual machine which can do like 1,000 TPS out of the box without any parallelism. Without like parallelism, not even included there, we can do sequentially 1,000 TPS. So that is a very important part that I think like sets us apart from every other ZK rollup. Like as we see also some optimistic rollups, but like every single other ZK rollup is less mature in terms of actual throughput capacity that they can handle. So this is one difference. The other difference is obviously we use state diffs and not call data for transactions, which only Starknet does. Everyone else is using call data, and state diffs give you some really interesting properties. For example, you can build volition, which is going to be important. I think the data availability is going to strike back. Like at some point, we will saturate the AP4844 data blob space, and the prices will start climbing like rapidly and steeply. That's my take. We'll see how long it will take us to get there, but I don't think it's going to be too long once the actual consumer use cases will start taking place on rollups. And I know for a fact, I know like there are a couple of really big, really famous projects coming to ZK Sync in the next few months that are aiming for mainstream market and are going to bring millions of consumers. And so like they will quickly saturate all of the available space, and Validium and Volition will become very important architectures that can only actually work with state diffs. And then the third major distinction I would say is that ZK Sync is the only stack that today supports native account abstraction. And that is massively important for consumer use cases. You want the consumers to not be bothered with technicalities. Like, I want to be able to onboard my friends, my parents on blockchain, on ZK Sync, on Ethereum, and let them just, like, I send them some virtual tokens and say, here are some dollars for you. Go ahead and start using NFTs and move your lives on chain. And today I cannot do this. It's hard. Like, I can send them ETH, but like, you need to explain gas, you need to explain seed phrases, all of that is very hard. So I'm really looking forward to the next generation of smart wallets that are going to use passkeys. That's something that ZK Sync gets support in the next upgrade. It's already implemented on testnet. The SEPCK R1 curve, which is supported in the mobile secure enclaves, will enable you to just do Face ID, Touch ID, and transact easily and secure your passkeys, like with the social recovery, with secure backups in hardware, in the traditional security services and so on. And this is what I believe will bring the UX to the level of the legacy Web2 applications or even better. And this is what will enable us to onboard hundreds of millions of people.
Follow up on that. How have you thought about embracing the EVM infrastructure versus what Starknet has done, which is kind of building everything from the scratch and then facing other challenges as they relate to rebuilding everything. But what's your take on why you guys went in that direction, and do you think that EVM is something that as so sticky from Ethereum that it will be the dominant virtual machine for the following 15-20 years?
It's the network effects of the technology. The network effects include number of developers who are already proficient in Solidity, number of auditors who can read the code, the amount of pieces of code that can be reused, the amount of best practices of like writing secure smart contracts, having the tooling that supports security, that each of these best practices have been written with blood and with like billions of dollars of lost assets in this book of of history. You cannot just replicate that. You can, it's hard to do it with traditional technologies already, but like with something as sensitive as smart contracts that require this ultimate security approach, it's really hard. So looking back, it was a really, really good decision. Like now in conversations with builders, with enterprises, with banks, with institutions, even with governments, we see that they value this a lot. This battle testedness, the richness. It's really hard to hire developers. One upside of building something new like Cairo by Starknet is that you can attract people who are interested in complexity. If you come and say like, oh, we build this software in Lisp, you're gonna attract some really, really smart and sophisticated people who are gonna be like, oh, we're gonna rewrite all of that in Lisp. But that's a tiny minority, right? So it's really hard to scale. If you're a founder of a startup or you are a CTO of an enterprise and you're thinking how you're going to be recruiting developers into your project, you want to pick from a pool of a very large allocation. I was CTO of several startups before Meta Labs, and I know that it's hard. You always want to bet on the most popular technology. Back in the day, they were competing like Web2 stacks like Golang versus, for example, Java and like Java Play and things like this. And Go was massively more popular because it was backed by Google. And so it was massively easier to find people who program in Go, even though it was kind of a simpler language where you had to do a lot of comparison work, but it was simple, straightforward, and had this network effects, right? And then, was a really good choice looking back to stay EVM compatible.
And so to take, Starknet's argument is generally that things are more optimized when you build from scratch. Do you agree with that, or do you not?
I do, but there is no reason why we cannot build it from scratch also with EVM. So one thing we're doing at Meta Labs is we have a really, really strong world-class compiler team who's working our compiler for zk-sync right now is based on LLVM. So we take the Solidity front end. So we take Solidity, we compile it to Yule, and from there we compile it to our zk-VM that is executed inside zk-sync. But the next step will be to just natively compile, build a native Solidity compiler that takes the source code, uses the best practices and all the proven techniques from LLVM to heavily optimize this code, produce two types of output, like EVM bytecode output, which is going to be better than the existing compiler already. And the second output will be basically native code, which will be, it won't be EVM, it won't even be zk-VM. It can be something like RISC-V. And then we'll have a highly optimized virtual machine which can execute this native code. That is going to give you the maximum degree of compatibility and performance on both, without compromising either. So your code will work exactly the same way as it works on Ethereum. You will be able to pass the test vectors and ensure that all invariance holds, but also have the absolute untoppable performance because you basically run native code on bare metal for your sequencer.
Makes sense. When you think of kind of the development milestones that you still have in front of you, to achieve the max scalability that you can. Can you talk about those and like what roughly? I mean, I know it's very hard to estimate these things, and we've generally been wrong historically about estimating when things will happen. But what do you think are the most important things for you guys in the next 2 years, and when do you think roughly you'll hit those milestones?
Sure, I can give you a rough overview of different milestones we need to hit. Don't take it as a sequence because the sequence is always determined by what is needed by developers in the market today. So the one really important piece that we're working on, we're focusing on directly right now is decentralization of the ZK Sync protocol overall. The network must be decentralized, it must belong to its community, and this is a non-negotiable. Like this, now is the time to actually do it. Now we've completed all the major blockers that were stopping this, and we're going straight down this line. Once the governance is decentralized, we also need to decentralize the sequencer to not have a centralized, like any central point of failure. We are also working on this. We have a decentralized sequencer testnet running. It's a matter of integration, and the integrations are determined by the bottleneck of, we are taking security very, very seriously. It's top of mind for everything we do. We pass security audits. We pass crowdsource competitions. We are on the largest crowdsource competition on Code Arena with $1.1 million for the bootjam upgrade. So like we're just gonna do it very, very gradually. Like we really want to make sure that things are battle tested, but decentralizing governance, the sequencer, and subsequently the prover, down to a point where the proofs can be generated by this broad network of GPUs running in basically at home or in custom clouds, is very important. Now, on the scalability side, I already mentioned the new virtual machine, which is capable of like up to 1000 TPS. It's coming on in one of the next releases. We are bringing the interoperability, which I described before. So like once you have the infinitely scalable single chain, you still want to have many chains. Like we call them the hyperchain network, with many different ZK Sync chains. Era being the first one, and more application-specific chains and generic purpose chains coming to form this big network where users can interoperate between any of them and any others. This is important because not all applications need to run on a shared sequencing layer. Like think of some games that have millions of daily users. They don't need to run on the same sequencer and share the same block space with like DeFi applications that are going to be heavily front-run by arbitrageurs and financial actors, right? Or think of a social network that also does not need to share it with games and other applications, right? Like, or think of financial, like, the banks we're talking to who need privacy, and they're going to be deploying Validium chains, but still be part of this big network. They need the Validium for the reasons that they basically need to keep the state private to themselves and only publish the rest, right? So once you have this multi-chain world, they must be interconnected, and we are really excited about bringing this connectivity layer very soon. And then, so these are the really big milestones, and there are a couple of others also in the background, but those are the big ones, really.
I have two questions to follow up on that. One, you mentioned banks and like the necessity to use private transactions. Why would banks and enterprises use something, like a blockchain or ZK rollup, if they can use databases? Like, what does it actually accomplish for them? In order, like, what are they verifying, or what are they, if it's private and not necessarily decentralized in this way, why is it important?
Believe it or not, they have the exact same problem as everyone else, as the users. They don't trust each other. Like, not in a sense that they don't trust, like they don't have good relationships, but they don't want to depend on each other for security. And they don't want to share the data. In some cases, in many cases, they actually are not permitted to share the user's data by the legislation of their respective jurisdictions. Like in Europe, you have GDPR. Your data must be on European servers. In the US, they have the US privacy framework. In Switzerland, Singapore, other jurisdictions, they have their own laws, and they must segregate this data. and they must come to consensus. Like they must be able to interoperate without losing this control. And this is a huge problem. They cannot run databases because the database, if it's verifiable, it's a blockchain. If it's not verifiable, it's basically a database that someone controls.
So an example of what you're mentioning would be like a settlement network between the banks or countries even that settles amounts of money without actually trusting each other.
Exactly. So some of them might want to build a network that is private. They just want, but even if they build a private network, they want to use the technology that is most battle tested, and they actually contribute back to the security of this technology because once they operate it and use it, there is a lot of technical due diligence coming from their teams, and it's kind of working both ways. But a lot of them want to use, actually, they prefer to use public networks because it gives them, especially like smaller ones or like banks, because you want, like, you want to be part of the internet. You don't want to build your own intranet internally. It gives you a lot of possibilities. It gives you this open access to anyone else. It's permissionless. Anyone can come and join. And then they derive the security, economic security from the underlying settlement layer. And Ethereum is by far the strongest one. Like giving the properties of the Ethereum network, the economic security of Ethereum stake is way more valuable than economic security in other networks that is like solely responsible for what's happening there. Because in Ethereum, remember, in Ethereum, the economic security of the chain, of the stake, is only protecting you from double spends. In other networks, it's like if you have a side chain, for example, then your stake of the side chain is actually controlling all the TVL, so they could steal these funds, right? So you need to think like, is the stake actually larger than the assets or not? If it's not larger, then it could be exploited in a profitable way, which is a nasty situation, and so on. But on Ethereum, that's not possible. The worst thing they can do is to create a temporary denial of service situation, and then the users will fork away and recover, right? So a lot of stake for a small amount of security work is really powerful, and that's why I don't see that's why they prefer Ethereum for like many of them.
When it comes to kind of mass scale applications, you mentioned that you know about a few that are definitely coming to ZK saying, it seems like historically there have been a few that onboarded, lots of users, but sustainable user engagement hasn't really been, achieved by anyone as far as I can tell. And then there's obviously a lot of interest in speculation trading, NFTs in general, but there hasn't been a use case where like my wife or my parents who don't care about crypto actually have to use the blockchain. Do you think that will happen in the next 2-3 years, and how confident are you that it will?
Honestly, so far I have not seen anything that would be like where I could easily onboard my parents on.
Yeah.
Like neither in terms of UX nor in terms of scale.
Yeah.
That would support, if you have fantastic UX and you all of a sudden you have the first application that goes viral and onboards millions of users, networks would collapse. None of the networks will be able to maintain the scale. It's coming this year. It's coming specifically with ZK networks, and this is why ZK is the end game. And with the UX that is enabled by native account abstraction and by this biometric signature verifications that are coming, and with all these new wallets, smart contract wallets, and like social recovery wallets, etc., that are being built. So like I'm really looking forward to the moment, and we're not there, but we're just a couple of months away from that moment where I will be able to onboard my parents, and I will onboard them. Like I don't want to onboard them by the virtue of having to explain to them, oh, here you have to do this step and this step. Oh, okay, this is too complicated. Like don't worry about that. No, like that's not interesting to me. I want to give them one link and say like go, or like send them like send them a link where they can claim $100, like $1,000, whatever, and say like, here's a link of really cool things. Go explore. Do it on your own. It's super intuitive, just like I onboarded them to internet like some long time ago, right? I just told them, look, it's so intuitive a child could use it, and they kind of felt compelled to like not show that they are like less intelligent than the child, and so they went and did it. I'm waiting for this moment with with crypto, with Web3, and this moment is coming. We're really, really close to it.
And any guesses on which application can actually be the breakthrough? Like, are you're just convinced that it's going to be decentralizing ownership and removing third parties, basically, and then creating apps that distribute the economic gains for the entire community?
It's just obvious to me that this ownership aspect is what's going to create incentives for us to really quickly onboard all of the world the moment we can actually give them something usable and scalable.
Mhm.
Because you cannot compete with ownership. You know, like you have one restaurant chain where you're not part of, and the other one which is kind of which you feel owner on. Which one are you going to be going to? It like we see it with Bitcoin, we see it with Ethereum, we see it with all of the rest of crypto. We see it with DeFi, we see it with meme coins. You know, all of those things are cultural phenomena that are we have to embrace them. We have to celebrate them. Some of them look, you know, crazy, but it's like so did the internet when on the dawn of its existence. It's perfectly fine. Like we just have to like go and have fun, and obviously be careful. Like you don't want to be, you know, like investing, like setting your flat and investing all of that in the meme coin. But you see that these incentive mechanisms actually work, and they work exactly as it was predicted by the great thinkers of the Austrian economy, from Hayek to Mises to, you know, like all the thinkers who were before them, the classical liberals, the you know, like Milton Friedman and so on. Like this is just gonna happen because it's a winning in the competitive environment against centralized older school approaches of the traditional Web 2. So I have zero doubt about that. Like I don't know exactly what is going to be the first application. I have my guesses. I have a couple of kind of bets that I believe, but I don't you know, like don't want to make predictions
Yep.
today. I just know that one of them, the moment we have UX, security and scalability, UX and security come together hand in hand. Like you can't, if you can lose everything you have in one wrong click, that is a terrible UX.
Agreed.
That is a UX you don't want to wish. Like I can't give it to my parents. They're gonna lose everything like next day, right? Not because they're stupid. They are very smart.
Yeah.
But like it's just hard to navigate. You don't know what's scam, what's not scam, etc. You need to make it safe. Once the UX supports safe interactions, like safeguards the users, holds them by hand until they grow and understand the landscape there, and the scale can actually support the going viral of one of these use cases, we will have one of those use cases. I absolutely know that.
Well, very much appreciate this. I have one last closing question, hopefully a little bit fun, a little bit challenging. Which projects do you think are currently pushing the innovation boundaries? Which are your favorite projects that actually are shipping something that you're impressed by?
Look, we have a couple of things in ZK Sync that are coming soon that are unique, that have not been possible before. But I don't want to take it prematurely. I want to go through the proper announcement and
Yeah.
like, you know, so let's just keep watching. Just subscribe to ZK Sync social, and you will see like we have really exciting things coming over the next 2 months. Like what I know today of. I promise you, it's going to be fun and entertaining.
Cool. Well, with that, I would like to thank you so much for coming on the podcast. This has been a super interesting one. I've certainly learned a lot myself. So, you know, would love to have you on again sometimes.
It was a pleasure. Thank you for inviting me, Larry. Thanks everyone to listen.
Thank you so much.